This is Secondary Math 2 Unit 7 review, and I'm going to go over the third section. I'm hoping to get all of the third section in one video, but if I need to split it up, I will. So when I'm using Trig to solve for right triangles, it's only asking for x in this case. If I was being asked to solve the whole triangle, I would need to find any missing side and the missing angle. But I'm just finding x on this one. But I'm using trigonometry, so I have to remember Sohcahtoa. So when I'm looking at this angle right here, I'm going to say that since this is my angle, this is the opposite side. Move this over a little bit. Okay, this is the adjacent side. And the hypotenuse. So, I'm using that angle because I have a number there. And I'm not going to use the 90-degree angle because we never use the 90-degree angle. It's only that one or that one. I could find that angle and then use it, but that's just an extra step. Now when I'm solving for x, basically I want to use either information I'm trying to find or information I have. I have the adjacent side. I want to find the opposite side. So I don't care about the hypotenuse at all. So I need the trig function that uses only opposite and adjacent. That's opposite and hypotenuse, adjacent, hypotenuse, opposite and adjacent. So I want tangent. So my statement is tangent of an angle is opposite over adjacent. And then I'm going to fill in the information I have. So tangent, and then the angle is this 21.3. That's going to equal opposite, which is in this case my x value, over adjacent, which is 7. Now I need to look at it as an equation where I'm solving for x. I have an x over here, and it's being divided by 7. So to undo that, I'm going to multiply both sides by 7. Because 7 divided by 7 is 1. So that's going to reduce. So I only have an x value on that side now. And on this side, I have 7 times tangent of 21.3. The 21.3 is the angle inside of tangent, so it's not like I can distribute the 7. So what I'm going to do is just type that exactly into the calculator. Again, making sure you're in degree mode. So I'm going to say 7. Let me see if I can make that a little brighter. 7 times tangent of 21.3. And then it tells me where to round. So if x is going to be 2.79185,956 stuff, the 10th place is right here. So one place after the decimal. So I'm going to look here. That number's bigger than 9, so I need to round up. Okay, on this one, we're going to do the same thing. So we're going to find the angle that we have information on, which in this case is that 29. And I'm going to say, okay, looking at that angle, This is the opposite side. This is the adjacent side. And this is the hypotenuse. So we have the hypotenuse. We're finding the adjacent. I don't care about opposite. So which trig function uses adjacent and hypotenuse? Adjacent, hypotenuse. So my statement is cosine of an angle is adjacent over hypotenuse. So I'm going to fill in the information I have. So my angle, I have my angle, cosine of 29 degrees is going to equal my adjacent side, which is x, over the hypotenuse, which is 8. So I'm in a similar situation over here where I have some trig function is equal to a ratio where the x is in the numerator. So I'm going to multiply by 8 to get rid of the 8 over there, because 8 divided by 8 turns into 1. And then I have 8 times cosine of 29 equals 1 times x. I'm going to use my calculator and say 8 times cosine of 29, and I get 6.9969 stuff. So I'm going to look at the tenths place. I'm going to round to the tenths place, so I'm going to look at this one, the hundredths place. That's a 9, which is bigger than 5. This needs to go up. For this to go up, this is going to have to increase as well. And it's good form to put a 0.0 to show that that's where you round it. Okay, so let's do the other two. So, same process. I'm going to rewrite Sohcahtoa up here. So, I'm going to look at my angle. I'm going to look at the angle. I'm going to set both of these up at once. And then I have the opposite side of that angle. So on this one, it's here. And then we have the adjacent side. And then we have, that's not the adjacent side, that's the adjacent side. And then we have the hypotenuse, which is always across from the 90-degree angle. Okay, so I'm going to look at the first triangle and say, well, I want the hypotenuse and I have opposite. Over here I want adjacent and I have the hypotenuse. So what I'm going to do is I'm going to pick the trig ratios that kind of match up with that. So opposite and hypotenuse and adjacent and hypotenuse. So this one, opposite and hypotenuse, is sine. This one is cosine. And then I'm going to fill in the information I have. So I have sine of an angle, which in this case is 26, equals the opposite side over the hypotenuse. And on this one, I have cosine of my angle and the adjacent side over here is x, and the hypotenuse is 12. Now the reason why I set these up at the same time was I want you to notice a difference in the equations. I have a trig function equals a ratio. In this one, the ratio has x in the numerator, but on the first one, it has it in the denominator. That placement matters. So what we're going to do is we're still going to follow the same kind of process to undo what's in the denominator. So I'm going to multiply by 12 over 1 over here. On this side, though, I have to multiply by x over 1. Because just like 12 divided by 12 reduces to 1, x divided by x reduces to 1. So then over here we have x times sine of 26 equals 2. And on this one we have 12 times cosine of 61 equals x. This one is ready to be typed into the calculator because x is isolated, it's by itself. This one's not. We still have another step here. So what I'm going to do is I'm going to say what is happening to x. Well, it's being multiplied by sine of 26. That's a whole thing. So I'm going to divide by sine of 26. And what that's going to look like is x is equal to 2 divided by sine of 26. And now we're ready to type both of them into the calculator. So for this first one, we're going to do 2 divided by sine of 26. So I have a 4.56. 5 is the tenths place. 6 is where I look to round. So because 6 is bigger than 5, then this rounds up. So I have 4.6. And then on this one, we just type in 12 times cosine of 61. So I'm rounding to the tenths place, so that 8. So I'm going to look next to it. 1 is smaller than 5, so the 8's going to stay the same. Okay. I'm going to continue with the next set of problems because they're going to be a little faster than those ones. So we're basically going to do the exact same thing, just now I don't have the angle. I have the angle I want to find. So in relation to that angle, this is the opposite side on this triangle. Opposite, opposite. Adjacent, adjacent, and adjacent. And then I have the hypotenuse, which is across from the 90-degree angle. Okay, and I still have to remember Sohcahtoa. So in this first one, I have the opposite side and the opposite side. In the second one, I have the opposite side and the adjacent side. And the third one, I have the adjacent side and the opposite side. So I'm going to pick the trig function that works with those sides. So what works with opposite and hypotenuse? Sine. What works with adjacent and opposite? Tangent. And adjacent and hypotenuse is cosine. Then I just fill in the information with what I have. I know sine of some angle is going to equal opposite over hypotenuse. Well, now this looks like what we were doing on the last video, typing it into the calculator. This is just saying take sine inverse. So on the calculator, we're going to take second sine of 10 divided by 13. And it says to round to the nearest tenth again. So 50.28 stuff. That's the tenths place. I look next to it to see if I go up or stay. So 8 is bigger than 5, so it goes up. So it's approximately 50.3 degrees. Okay, I'm going to go out of order and actually do 17 next. So cosine of my angle is adjacent over hypotenuse. I do cosine inverse. And type that in. So second cosine is going to be 3 divided by 11.4. One thing I want to show you. So if you want to type in visualizing the fraction, which is sometimes better, if you do alpha y equals. This ND stands for numerator denominator. And then I can actually type in how it looks. Okay, so we get 7 is the tenths place, 4 is if I'm looking to round, so 4 is less than 5, so it stays the same. So we get 74.7. Okay, and then this last one, tangent of my angle is opposite over adjacent. So I'm going to type in tangent inverse of that fraction. So tangent inverse, so second tangent, alpha y equals, to get my fraction, 4.8 divided by 3.7. 52.4 degrees. Okay, and that's it for that section.